Hello and welcome to a lesson in science called Introduction to Acid and Base for Standard 8. And in this video, we will be doing all about acids, their uses, their properties, what are acids, and everything else you need to know about acids. Look at all these food stuff here. Some of them are fruits. Then there is tamarind, there is Coca-Cola, and we have alcoholic drinks, lime, some more drinks. And if you look and think about these, all these food stuff and the cold drinks and the alcoholic drinks, one thing that they have in common is that they are all sour. And they are sour because of the presence of acid in them. What are acids? An acid is any substance that in water solution tastes sour. It changes blue litmus paper to red and is corrosive in nature. So we have some indicator called blue litmus paper. So when we put that in an acid, it turns red, and so we know that that liquid is an acid. And acids are corrosive, meaning if they drop on a table or on any surface, they harm that surface. They are harmful in nature. They destroy that surface. Okay. Now, there are two types of acids. One is a natural or organic acid coming from plants, plant animals like lactic acid or citric acid. And the other type of acid is the strong mineral acid, which is like sulfuric acid, nitric acid, hydrochloric acid, etc. Now, some mineral acids are hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4, and carbonic acid H2CO3. Now HCl, HNO3, H2SO4 and H2CO3 are the molecular formulas for these respective acids. Now, our daily diet consists of natural or organic acids. Now, these are mild in nature. They are not corrosive. Okay, they are not harmful like the mineral acids. And some of them are like vinegar, acetic acid. The food stuff is orange, which contains ascorbic acid. Tamarind contains tartaric acid. Tomato has oxalic acid. Curd has lactic acid. And lemon has citric acid. So here we see the difference between mineral and natural or organic acids. If I take 1 teaspoon of salt and put it in water, or I take, like in the second beaker here, 20 teaspoons of salt and add it in water. Now, the one which will be more salty and little thicker and denser is the second beaker because it has a lot of solute in it. So when there is more amount of the solvent, that is like water, something that dissolves a solute, then we say that it is dilute. But when there is a lot of solute in water, then we say it is concentrated. So 1 teaspoon of salt in water is a dilute solution, and 20 teaspoons of salt in water is a concentrated solution. So look at this over here. Now we have two beakers. There is sugar called sucrose in both the beakers. In the second beaker we add dilute sulfuric acid, and in the first beaker we add concentrated sulfuric acid. After 15 seconds, can you see the fumes coming out? It starts being corrosive, it starts burning up, whereas the dilute solution does nothing. Both of them contain sulfuric acid. The only difference is that one is concentrated and one is dilute. And after 1 minute or 60 seconds, see what happens. to when that as concentrated acid acts on a sugar. So this is how corrosive concentrated mineral acids can be. Strong concentrated acids are converted to dilute acid by slowly adding them to water. Dilute acids are less harmful than the corresponding concentrated acids. So we just can't take, water and put it into acid. There will be an explosion, like it will just come out and it can harm you. So we what do? We slowly add drop by drop of the concentrated acid into water and make them dilute. Substances which change their color in the presence of an acid or base are called indicators. So you can see these are some of the indicators: red and blue litmus paper, methyl orange, which are commonly used, phenolphthalein, and methyl red. These are called laboratory indicators. Test for acids using indicators. These are the names of the indicators: blue litmus, red litmus paper, methyl orange, phenolphthalein, and methyl red. Now, the color of blue litmus paper is blue, but the color in an acid is red. So, when you put blue litmus paper into an acid, it turns red. When you put red litmus paper into an acid, it remains red. Methyl orange is orange in color, but when it goes into an acid, it turns pink in color. Phenolphthalein is colorless; it does not change its color in an acid. And methyl red is red in color, does not change its color in an acid. So if I want to know something is an acid, I use blue litmus paper, it changes its color to red, or methyl orange changes to pink. The other three don't change color in an acid. Okay. When laboratory indicators are not available, then we can use natural indicators, which can be made using several domestic substances which we have at home. These are some of them: filter paper, rose petals, red cabbage, hibiscus, beetroot, okay, milk, baking soda, dish soap, lemon juice, vinegar. All of these can be used to indicate whether the substance we want to know about is an acid or it is a base. And because they are made at home, they are called natural indicators using natural substances. Properties of acids. First one, acids are sour in taste, as you already know. Then acid molecules contain the hydrogen ion, that is H plus, as the main constituent. So acid in water, when acids are put in water, they will show you these H plus ions. If you remember, HCl, H2SO4, HNO3, all the three acids had H plus, the hydrogen ion in them. Another property is that acids react with metals to form hydrogen gas. If you can see in the test tube there is acid with some metal like magnesium or zinc. Okay, so when these two react, bubbles come out, and these bubbles make a pop sound when a candle is lit. Now that is the test for hydrogen gas. When you light a candle in the presence of some gas and it makes a pop sound, that means that gas is hydrogen gas. And how do we get hydrogen gas? Acid reacting with metals. Blue litmus turns red in an acid. So when we take blue litmus paper and you put acid on it, it will turn to red. That is a very big indication that it is an acid. And the last, property is that acids react with carbonates like zinc carbonate and calcium carbonate, and CO2 gas is liberated or given out. We now come to the uses of acids. Acids are used in the production of fertilizers, chemical fertilizers. Acids are used in the production of explosives, that is, explosives meaning fireworks, dynamite, etc., oil purification, medicines, dyes, and paints. Hydrochloric acid is used for the preparation of different types of chloride salts. Now, hydrochloric acid is HCl. H is hydrogen, Cl is chlorine. So, different types of those chloride salts are formed by, hydrochloric acid is used to prepare these salts. Now, dilute H2SO4, that is sulfuric acid, is used in batteries, bigger batteries for vehicles and the smaller battery. Dilute HCl or hydrochloric acid is used for sterilization of water, and acid is used in making a white paper from wood pulp. So from wood we get paper. That paper is not very white. Acid is used to make it white in color. Now we have seen that mineral acids are harmful to the body. But there are several organic acids which are already present in our body and in plants which are useful to us. Now, one of them is DNA or deoxyribonucleic acid, present in the cells of our body, which decide the heredity properties, meaning decide how the child is going to look, how the child is going to be, compared to the parents. That is called heredity. So we have an important acid in our body called DNA, which decides that. Apart from that, proteins which are part of our body cells are made of amino acids, and the fat of our body is formed by fatty acids. So, in short, the properties of acids are sour taste, turn blue litmus red, reacts with some metals to produce hydrogen, and dissolves carbonate salts, releasing carbon dioxide.